Hi there, I'm Jose Wesley, and today I'll talk about the Whiro Framework, a tool that allows us to inspect the internal state of programs. The internal state of a program is formed by the values that said program manipulates. Such values are stored in different memory regions, like stack slots, the heap, and static memory. The ability to recover and to report this state is useful for many applications, as we shall see soon. Reporting the program state is a well-solved problem for type-safe languages, in which the type of each variable can be determined either statically or dynamically. However, that is not true for type-unsafe languages, in which size information is not associated with memory regions, and there is no distinction between scalars and pointers. Several important programming languages are type-unsafe, like C, C++, and most of the assembly dialects. A wide range of applications emerge from using Whiro. For example, it could be used for debugging or to add verifiable outputs to automatically synthesized programs and to data visualization purposes. Whiro lets programmers observe the shape of the data structure that exists in the heap. For example, in the figure on the screen, we can see in A a data structure from MyBank's Patricia benchmark. In B, we can see a hash table, and in C, a binary search tree. All of those figures were produced using Whiro. Whiro is a software that allows us to inspect the internal state of C programs. It achieves that using a combination of program instrumentation and the library that is linked to the program. That library contains important data structures and routines that will enable Whiro to precisely report the values that a program is manipulating. The program state is reported at inspection points. Inspection points are routines that are inserted in the program at different points. In each one of these routines, the values of the visible variables at that corresponding point are reported. In principle, every program point where a new instruction can be placed can be inspected, but in the current implementation, Whiro creates inspection points right before the return points of functions. The variables are reported with a calling context, formed by the name of the variable plus the name of the function and a call counter value. There is a value that corresponds to the nth call to that function. Whiro allows changes the form of the program to report variables that are dead at inspection points. Whiro is implemented in LLVM and is fully automatic. Finally, Whiro is highly customizable. The user can choose the amount of program state that is tracked. Currently, we support the following customization options. We have the filter options that will filter the program state. We have OM that will inspect only the main function of the program. PR that will follow the context pointed by pointers, so we'll print the values that are in regions that are pointed by pointers. We have STC that will inspect only the static variables. STK that will inspect only the variables that are in stack. HP that will inspect the reachable heap. We have the FP that will inspect the entire heap at every inspection point. And we have the debug options. Those are Memon that will show what Whiro is doing during the instrumentation time, and we have TT that shows information about the types that Whiro is collecting and will use to report the values of a program. Currently, the only software necessary to run Whiro is LLVM. If you want to use Whiro script, Bash will be also a requirement. To install LLVM, just follow the commands on the screen. Just clone the official repository and build the source code. One important thing to notice is that Whiro was developed on the top of LLVM version 10.0. Subsequent versions might break the program due to changes in the namespace. So right after cloning the LLVM repository, you might want to check out the tag to the 10.0 release. So just type this program right before building the LLVM. Now to install Whiro, we follow a similar process. First, set some environment variables to tell CMake where to find your LLVM installation, then type the commands on the screen to install Whiro. So let's see now an example of Whiro running in a program. I have already downloaded and installed Whiro here, and for this example I'm gonna use this program here. That it simply manipulates a binary search tree. We have a function that inserts nodes into that tree, and we have the main function. We will be inserting nodes with infos 5, 3, and 7. So let's jump into the benchmarks folder. You see that we have here just the program itself, the scripts to run Whiro, and the readme file. I'm gonna run Whiro using the script, so I'm gonna pass the program as an argument and the options that we have. First of all, I'm gonna use the OM option. That means I want to instrument only the main function. I wanna inspect the state of this program just before the main function returns. So let's run it. Whiro collects some statistics, and if you want to know more about what those statistics mean, you can take a look at the repo, because it's all explained in there. So now notice that we have a lot more files. Those files were created during the compilation and instrumentation of the program. Please pay attention to this file here. It's called typetable.bin. This file describes all the types that exist in the program, and our executable will read this file at running time. And we have this new folder called the BST output, and the output file that was created by Whiro is within that folder. So let's take a look at and see how it looks like. And the output file always have the same name of the program plus the suffix output. As you can see, we have just two variables. They are the variables at the main function. The variable n, which is the root of our tree, and it's reported as pointer to struct nodes. And we have the non-nodes variable, which is static, and it has value 3 at that point because we created 3 nodes into our BST. Notice that the tree is reported just as a pointer to struct node. That happened because I didn't follow pointers. I just wanted to know if the variable was a pointer or not and the type of that pointer. If we want to see the contents of the tree, we need to add one more option. That's PR. It stands for precise. That means we want to enable the precise instrumentation mode, so we will be able to track the contents of the tree. So as you see, the output changed. Now we have all the information regarding that tree. We could report all the reachable memory slots on that function. And just to give you a notion, that's the tree we have in this program. So we have 3 nodes and if we compare that tree with the output, we can see that Whiro precisely reports everything. We can see here that we have 5 at the root of the tree. On the left we have a node with 3 on it, and both left and right of the node tree, they are null. On the right of the root we have a node with the 7 value on it, and in both left and right it's null. And we have the non-nodes variable again. So you can see that Whiro reports exactly the shape of that tree. Now let's take a look at some more options. I'm gonna add the STC filter, that means I'm only interested in at static variables. So the output should contain just one value. And as you can see, we have filtered it, so we were interested only in the static functions, and we will report only the static functions. And we can do the same thing with other memory regions. For instance, I'm gonna inspect just the heap, so we have only the tree. And yes, there it is. You only have the nodes of the tree, the memory allocated in the heap, because we asked Whiro to inspect only the heap. And if I take the option off, the OM option off, you can see that we will inspect the tree at every call of every function. So the insert tree will be called many times, and we'll be able to see the value of the tree at each call of that function. You see that we reported values at the first call of insert tree, at the third call, the second call, fourth and fifth, and so on and so forth. So Whiro is highly customizable, and you can play with it the way you prefer. So you'll be able to report variables at different points, at different memory regions, and so on and so forth. So that's all I had to show today. If you want to try Whiro, you can click on the link below the description that will guide you to the repository. There you can find also more information about Whiro and how it works. Thanks for your attention.